This video is about recognizing and identifying local min and maxes on the graph and determining what happens to a graph as x approaches a particular value. So first we need to know what a local max and a local min are. A local max is a point which is higher than any other point. So in this case we have a local max. Now you can have a couple local maxes or you can have a couple local mins which are a point that are lower than other points. The local max and min though are going to come to either a hump for a maximum we can think about, or we can think about a valley for a minimum. Both of these points that are called local maxes and local mins are vertices of our graph. So looking at the graph, do we have a local min, a local max, both or neither? So we're looking for a hill or a valley to figure out if we have a local max, min, both or neither. So number one, we have a high point, which would be our local max. We have a low point, which would be the local min. So in this case, we have both. In number two, this is just a straight line that's decreasing from left to right. There's no peak or valley, so in this case, this is neither. In number three, we have a low point, which would be our local min. So in this case, we only have a local min. In number four, notice that we have 1, 2, 3 higher points. Those are our local maxes, and we have 2 local mins. So in this case, we have both. In number five, we have a point that's higher than everything else to create our little hump or our peak, which would be a local max. And in number six, the same thing would also be a local max. So let's look at some other aspects of graphs that can help us determine different parts about a graph function. So an interval is a specific part of a graph function given two endpoints. Sometimes the endpoints will be numbers, sometimes the endpoints will be these infinity signs. So like here, the negative infinity is always going to be our left arrow. So anytime we see negative infinity, we're looking at the left arrow. And when we have positive infinity, like down here, that was going to be looking at our right arrow. So we want to look at the intervals and put them together. So in this case, going from the left arrow all the way to 0, that would be our A. Then going from 0 to 5, that would be our B interval. And then the last interval going from 5 to the right arrow would be C, which is going from 5 to infinity. So along these intervals, we can say that a function is either going to be increasing or decreasing. If you traveled up, the function is increasing. So when we were tracing the graph over here, A went up and C went up. So we would say that they were increasing over those times. B is going downward, so that would be a decreasing function. So we're going to look at, is the function increasing or decreasing along the following intervals? So the first interval is from negative infinity to negative 2. So remember, negative infinity is the left arrow. So we're going to go until we line up with 2 on the x-axis. And as we traced, we were going down, so this would be a decreasing interval. Then we're going to look at the interval from negative 2 to 1. So lined up with negative 2 on the x-axis, follow the graph until we line up with 1 on the x-axis, and notice that this time we went up, which means we are increasing. So each time that you get to a peak or valley, you should be switching from increasing to decreasing. So before you switch decreasing to increasing, now when we go from 1 to 7 following the graph, again, this would be decreasing. And last, when we go from 7 to infinity, so 7 to the right arrow, we went up again, so again, this is increasing. We can also look at a graph's behavior, so that as it approaches a certain value. So in this case, when we have x approaches negative 3, we're going to say or as x is getting closer to -3. So as we follow our axis until we line up with -3, we're following our graph, and it can be from either direction. So it can be from this direction or from this direction. What value do we approach? So we're looking for what is the y value at that x value. So if the x value is -3, in this case, the y value would be 5. When it says x is approaching 0, so x is 0 is over here on this red dotted line. So as we approach it from either direction, what y value are we getting closer to? And in this case, we're getting closer to -5. Now, the trickier two are the end behaviors, which is a positive infinity and the negative infinity. So as x approaches infinity, f of x, now remember infinity means that we're going to just keep counting on and on and on forever. And the reason that we draw arrows on the edge of our graphs is to show that the graph continues forever in the direction. So if we have the right arrow and it's pointing up, that means our y values are going to continue to get greater, which means that they're going to be continuing to go to infinity. As x approaches the negative infinity, so the left arrow, this arrow is pointing down, which means that we are going to get closer and closer to negative infinity because the y values are going to continue to grow in a negative direction. Use the graph to evaluate the function. So let's try a couple more examples. This time, instead of saying x approaches that number, we're going to say f of x. So we want to find what that value, y value is given the x value. So in the first one, we have f of -5. Well, f of -5 is right here. So what's the y value? The y value is 0. F of -3. So -3 is over here. This time the y value is 5. F of 0. So here's 0. So we want to know what the y value is, which would be -5. And at f of 4, here's 4. So our y value is going to be 0. When we are saying what values make x equal to the function equal to 0, we are looking at a point on the x-intercepts. So we want to know wherever it crosses the x-intercept, that's going to be considered a 0. So we have 3 zeros. We have 1, 2, and 3. So the 3 zeros is when x equals -5, when x equals -2, and when x equals 4. Use the graph below to answer the following question. So, does this graph have a local max, local min, both, or neither? Well, we don't see a peak or a valley, so this is going to be a neither. Now, these are special cases of when x approaches infinity and negative infinity. Instead of saying that it is going to approach infinity or negative infinity, the arrow this time is not pointing up or down. So if we say x approaches infinity, this arrow is continuing to get more and more closer to a horizontal line, which in this case is the x-axis, and the y value of the x-axis is 0. So we're going to go to what number the arrow is getting closer and closer to. When we have x approaches negative infinity, we're going to continue in this direction to get more horizontal towards the x-axis, which means the y value is getting closer and closer to 0. What values of x for this function equal 0? In this case, we're never crossing the x-axis, so we have no zeros.